Data can be transformed into various data figures. For example, pie chart. Pie chart can be used to represent proportional differences in data categories. Bar chart also can be used to represent proportional differences in data categories. Next is histogram. Histogram is a graph in which the frequency of individual measures is indicated by the height of the bars. Next is frequency polygon. As you can see here, the frequency polygon employs discrete point at the middle of each group or class interval. As you can see here, this graph is in normal distribution. A normal distribution or Gaussian distribution takes on the bell shape because it is symmetrical. That means each half mirrors the others. Unimodal, that means the distribution has just one most frequently occurring values and just one peak in the frequency distribution. And the last one is its standard deviation is about 1/6 of the range. This is an example of normal distribution. As you can see here, the mean, median, and mode value are the same. However, when there is an outlier, it affects mean, but not the median or mode. As you can see here, if an outlier at the lower end of the distribution, it will affect the first quartile. But if the outlier is at the upper end of the distribution, it will affect the third quartile. So, when a data distribution is not symmetrical, it is skewed in the direction of outliers. We can determine whether the skewedness is positive or negative by comparing mean and median. We also can calculate the skewedness using this equation. The left graph shows the distribution with positive skew and the right graph shows the distribution with negative skew. We can determine the percentage data distribution by referring the standard deviation from the mean. For example, one standard deviation from the mean represents 34.13% of the data. Another term that is important for distribution is kurtosis. Kurtosis describes how much spread there is in a distribution. There are three types of kurtosis: mesokurtic, platykurtic, and leptokurtic. Mesokurtic refers to the normal distribution, while platykurtic refers to distribution with too much variability or negative kurtosis. And the last one is leptokurtic, refers to the distribution with too little variability or positive kurtosis. This is the equation which can be used to determine the kurtosis of a distribution. As you can see here, this is the graph for platykurtic, mesokurtic, and leptokurtic.